To get started with actually building your CNN model, you need to ensure that you have created the storage buckets. So let's go ahead and see how to create the buckets and how many of them you're going to create. All right, so this is my projects page on the IBM Watson Studio. And now we're going to go to the services and then go to data services. Since we're talking about storage, we need to be on the data services tab. Once you're here, you can first check if you do have a cloud storage object, which in my case I do, and you should also, if you have followed the previous sections. All right, so let's go to actions and go to manage in IBM Cloud. So click on that. All right, so this is my page for my cloud storage object. So I have 3 buckets here. So what you should see is only the first bucket. So this is going to be your project name followed by this tag. So of course this project name will be different depending on what you used. Now what you have to do is create 2 buckets like I have created, one for training data and one for the training results. So the way to create a bucket is to simply go here, say create bucket, and you can give it a name. So let me give it a name, for example, training data bucket. So you can change your region and say create. That's it. So there you go, your bucket is created for you. So you can go back on the object and check how it looks like. So you have now the training data bucket. So go ahead and create another one called the training results bucket. Of course, you can name this whatever you like and say create. So there you go, buckets are created, and I can go back and show you the big picture here. All right, so what you should see after this step is 3 buckets, the old bucket and then 2 new buckets which you just created. Perfect. So there you go, you have created your storage buckets. Now we have to upload the MNIST data. So on this IBM example page, you have a dedicated page for the data. So this is what you're going to download. So let's go ahead and click on this. So if you have logged in, this will show you the download sign. If you have not logged in, go ahead and log in. If you already logged in the IBM Watson, this should obviously authenticate you by itself. This dataset has 4 files. So one is the MNIST Keras train.pkl. This is the pickle format. So this has the images and the labels for training the model. Then you have the MNIST Keras validate.pkl. So this has the images and labels for calculating the loss and evaluating the metrics at the time of each iteration. Then you have the MNIST Keras test.pkl. So this is images and labels as well. This is used to measure the performance of the trained model. Perfect. Then finally, you do have the test payload, and this is in the JSON format. Go ahead and download and unzip this data. So when you do that, this is going to look something like this. So you have the 3 files here in the pickle format, and then you have the payload in the JSON format. All right, perfect. Now let's go ahead and upload the data which you just downloaded to your training data bucket. So for you, this is going to be training data bucket right about here. For me, this is going to be training D, which I have already uploaded. So I'm going to show you how it looks like. So there you go. I have 3 files. Now I can also show you how this workflow looks like. So let's go to training data bucket and then simply click on upload and say files and basically say standard upload. Select your files, so go for it, say 1 2 3 and then say okay. That's it. So just like you upload any file. So this should take you some time and then you'll all be good to go. So now you have uploaded the data. So the next step is to create a project. You already have a project which you have created in the previous sections. If you have not, we can see how to create a project. The next step is to build and import a new flow model. All right, let's see these two steps together. So I am on my landing page of IBM Watson Studio. If you don't have a project, please go ahead and say new project and select complete, say OK, give it a name, and then you can create a project. So for me, I already have a project, so I'm going to say cancel. And then if you do have a project, so go ahead and select your existing project. There you go. So these are all the assets you already have in your existing project. For me, this is how this looks like. So now what we're going to do is we are going to create a new flow model. So in the previous sections, we saw how to create a machine learning model. So we clicked on the new Watson machine learning model, and then we went along the workflow. Now what we're going to do is we're going to come further down, and you're going to see this modular flows, and here you're going to click in new flow. Now I'm going to delete this. Okay, so I don't have any flows now. Let's get started from the beginning. So go ahead and say new flow. So what we're going to do is we're going to use the IBM example to get started. So we're going to go to the from example tab. All right, and here you see there are 4 examples. So we're going to use the MNIST example. So select it and say create. So there you go. So the name of the flow is single convolution layer on MNIST, and this is how your layer looks like. So this is very much the architecture what we discussed. So you have the input, you have the conv layer, ReLU layer, pooling layer, then you are flattening it, you have the fully connected layer, you have softmax, and then you're using the loss function, and this one uses Atom, so we'll see how to change that in the next iteration. And then you have the accuracy. So just to give you a quick walkthrough here, so here if you click on this specific icon, it opens up all the components for you. So for example, input, activation, so you have different activation functions, softmax, bar, ReLU. Then you have the convolution layer, so convolution layer, pooling layer. Then you have core functionalities like dense, so this is the hidden layer, fully connected. You have dropout, you have flatten, you have reshape, concat. So all these functionalities you have here. So you have metrics, you have the different loss functions, you have normalization, embedding. So this is recurrent, we'll take a look at it later. And you also have the optimization, so you can use different algorithms here. So in the first iteration by IBM, it uses Atom. So we'll go along with it, and then we will change this to SGD, and we'll see what happens. All right, so let's close this back here. So that is the icon here. So next we have the download button here. We'll see what this does later on. Then we have the publish button here. So this is how you're going to publish this specific flow to the repository, and we will use it later on in the experimentation layer. All right, let's get started. Double click on the image data. So this is basically a component, and you have to connect this to your cloud storage repository. So go ahead and say create new connection. So you can simply hit on that, and you can give it a name, whatever you like. For example, new connection, and you can say create connection. So there you go. I have 3 connections. These are my existing connections, and now I also have new connection. So there you go. You see the buckets option. So if you click on the drop down, you'll see all the buckets available for you. For me, I have all my files in the training D. So I'm going to click on training D. There you go. So what's happening is the data, this data input data wizard is able to understand that the training buckets have 3 files, and this is how this is designed. So you need to basically point to the train, test, and validate files, right? So we have 3 files. So you basically drop down and tell that, okay, this is the train file, this is the test file, and this is the validation file. There you go. What we have done now is you are using the image data input, then you have created a connection to your cloud storage repository, then you chose your correct bucket where you have uploaded the data. Then you are pointing to the training file, test file, and the validation file. That's it. So let's look at the different components here and if this matches the architecture which we discussed. So let's first go to the conv layer here. So simply double click on it and you see here that it has 64 filters just as we discussed. This is dimension of 3 by 3 and this is using a stride of 1. So we discussed 2, but this is a stride of 1. You can obviously change it if you like. So bias is 0 here, and then the weights are null. There's no regularizer for weights, and then there's no bias regularizer, and so on. So this is plain vanilla. And what's important to notice is the number of filters right now, the dimension, and the stride. Next is ReLU. There's not much to do in ReLU. So if you can see the negative slope, we're not going to touch that for now. In the pool D, as you can see, the dimension is 2 by 2 and the stride is also 2 by 2. Pooling function, which is very important, is we're using the max function. Now going to flatten. So this is basically going to flatten your multidimensional vector. Then this is the fully connected layer. Again, this is important because you need to check the number of nodes. There you go. This is the number of nodes. You're not going to use any bias and no regularizer as well. That's for the dense layer. And then if you come to softmax, there's nothing much to see. And then if we can actually go to cost entropy, we're not going to touch anything here. Atom is learning rate, which you can change if you like. This is starting with 0.001 and decay is 0 and beta is 0.9. All right, so we're not going to touch all of that and we're going to publish this project. So this is where you're going to click and it's going to say publish training definition. So that's the naming convention here. So you click on that. So you want to change this name definitely. So I'm going to name it MNIST live I1. So iteration 1 and this is live MNIST. All right. So this is the machine learning instance or service. It's automatically associated, and as you have only one option, nothing much to change here. So there you go. You can say publish. So that's it. So your training definition is successfully created. Now you can download this as a flow file to be used later, or you can download this as a TensorFlow code, which you can obviously use with TensorFlow, Keras, Caffe, and PyTorch. So this is pretty cool. As you can see, the reusable code and reusable flow files. All right, perfect. So now this is complete.